Alright folks, here we are with another ProDigi 3 tutorial, and this one is on walls and barriers. Alright, here we have our hero sprite and our barrier sprites. Now if you're creating a game with multiple levels, our tendency is to create multiple different kinds of barriers. For example, this is a forest level, and here you see the forest and bush sprites. But maybe the next level is on a mountain of lava, and therefore you need to make lots of lava and mountain sprites. And then the third level is a snow level, so you have to create snow walls and barriers as another sprite, and so on. And what happens is you end up bogging down the hero with all this different code that it needs, because the hero needs to recognize all these different barrier sprites. And that also can slow down your game. And speaking of slow, if I'm going too fast, feel free to go ahead and rewind and watch these videos again. Make sure you really understand the concept, because if you know the concept, you can debug. But if you don't know the concept, you're going to be up the creek without a paddle. Alright, so here we go. Here is an easier way to create barriers all over your maps without creating a bunch of extra sprites. We are going to use the clone technique. And the clone technique is a good technique because the code that allows these two sprites to interact gets copied into the clones. So you only need the code once and enjoy the benefits for all of the clones. So for this simple little barrier we created, I have some very simple code in this barrier sprite. It says, when this green flag is clicked, go to 0, 0, the center of the stage, switch to your vertical costume, and then show yourself. And then go ahead and create a clone of yourself. See, this is where all the code stays in the clone. Then you need the when I start as a clone. So when I start as a clone, I need to go to 0, 0, just like this one. But I'm going to switch to a new costume called horizontal. And here's the key, folks. When you have multiple costumes, they can act as new sprites because they're clones. So this clone is now going to switch to its horizontal costume and show. And you can see in the costumes here I have a vertical and a horizontal costume. Let's say I needed this same sprite to be hot lava rocks. Well, those could be down here. I could add more costumes and more costumes for a snow level and so on. Later we'll show you some advanced code to map these barriers and these clones all over your level so that you can create interesting levels and areas to explore. Alright, so let's get back to this code. This is what happens when we press the green flag. First sprite shows up here, it makes a clone of itself, and it shows up horizontally. And there you go. So now that we have our barrier, we need to code our hero sprite to interact with this barrier. Basically, to know when it's touching the barrier, and then experience an equal and opposite force. Newton's third law. Alright, so here we go. Where do we start? Let's start with our hero. And right now we have our movement code. If up, down, left, or right arrow is pressed, we change our location on the Y and X axis by a speed of 4 pixels per second. Here you can see that there. And by now you guys should also know that the X axis runs left and right. And here you go, X axis. And the vertical axis runs up and down, which is the Y axis. And when we're going to the right on the X, that's positive. And when we're going to the left on X, it's negative. Move up, that's positive Y. Move down, that's negative Y. So what we want to do is basically have our hero, or have Scratch check to see if our hero is touching this sprite. So what we would normally do is say, well, if we're pressing the right arrow, when we press the right arrow, yes, move us by 4 pixels per second in the positive direction, but also check to see, so we're putting another if statement in here. Remember, ifs are a way of checking for something. If we are touching the barrier. Alright, and I'm actually going to show you this way that kind of works, but it causes some glitches, and I'll show you a really cool way to take care of this. So we're going to go, once we're touching the barrier, we will experience an opposite force. So if we're moving an x positive 4, we're going to move x negative 6. So this will bounce us back a little bit. Let's try this out. Green flag. If I am moving to the right and touching the barrier, I get bounced back. Voila, code is working. Alright, let's go ahead and throw the rest of this code in all 4 directions. Switch out the y-axis because we're going to be moving up and down now. And now you'll see that when we press the green flag, aha, it's already glitching. Good. So you guys will see why this is happening in a second. But for the most part, it looks like it works. See, it can go from the left, I can go from above, I can go from the left again, I can go from the top and move down, and I get blocked. Here's the problem though. Because we have animations, our costume's not always going to be the same. You can see that we have a costume where the shield sticks pretty far out past the back of the hero. So if the hero happens to be moving towards a barrier and decides to turn around and fight an enemy or something or explore another area, so let me turn around, what happens is the back of the shield is now touching the barrier. And if we're going to be walking this way, we'll be pressing the right arrow. So let's look at this code. If we're pressing the right arrow key and we're touching the barrier, move us in a negative direction. So instead of me walking freely away from this barrier, the barrier is going to be sucking me back with force. And there you have it. So thanks to my good friends Trevor and Mr. Kenneth, we've cracked this code, and actually they're responsible for a lot of the code in this game. It's a great team collaborative work. We hope you guys enjoy it. Here is the way we crack this code. Thank you, Trevor. What we do first is we need to think about what we want to happen. We want to create essentially a hit test, a nice clean rectangular shape that doesn't stick out or protrude in it past the back line or front line of our character. So we're actually going to add a costume to our hero sprite, and we can call this hitbox or hit test or whatever we want to call it. In this case, we're going to call it the hit test, hitbox. All right, and always use vector, folks. It's much more forgiving than the bitmap mode. Okay, now that we've got a hitbox, what we're going to do is tell Scratch to check this if this is touching our barriers, because no matter which way it's facing, it's not going to accidentally touch the barrier while it's facing the other way, since it has nice even sides. Thank you, geometry and geometric shapes. So this code is no good, my friends. We're going to get rid of these if statements. And what we're going to do is create a new block. Make a block, call it hit check, and you'll get this nice big starting code script here. It says define hit block, and then basically everything you write underneath is going to define what this block does. We also create a new variable called costume, since we're going to be interacting with this costume called hitbox. So make sure you got those two things set there. What we want is for when the green flag starts, or when this block of code starts, called the hit check, when the hit check starts, we want Scratch to remember which costume we left off on. So were we walking right, left, up, or down? And because we want it to remember that, we're going to set our costume variable to whatever the current costume number is at. What does that mean? It means all of your costumes have a number. This is 9, 10, 11. So whichever one we left on, for example, this is 9, then we will set our costume variable to 9, to the costume number. And why does that matter? Because at the end of our code, we are going to say, go ahead and change our costume back after you've done this hit check. Change our costume back, switch our costume to whatever the costume variable has been set to. So it does a quick check and it switches you right back to your action costume. That way it goes unnoticed. Alright, so the next thing we want to do is that if we're moving around on the level, we basically want Scratch to check if we're touching a barrier. Because if we're touching a barrier, we want to experience an opposing force. So since this is our moving around code, we can add the check there. So more blocks, hit check is our block. And this kind of works like a broadcast and receive. If you remember the events, broadcast and when I receive. This is like the broadcasting block. It's going to do a hit check, and then it's going to broadcast hit check, and then this will run. So this is like when I receive hit check, do this. So every time we're moving, we want a hit check. And I should have duplicated this so I can do this much quicker. Quicker, that's a new word I made. Alright, quicker, here we go. Hit check. Always hit check. So now that it's hit checking, we're going to need to run some code. If it's hit checking and we're touching the barrier at this point, then we want to experience a negative force. So this is where we can add some code here. If it does a hit check and we happen to be pressing any of the arrow keys, meaning we're walking into this barrier, we're touching the barrier and we're pressing the arrow keys, we want to experience a negative force. So if we're pressing the up arrow, hit us with a negative 6 on the y-axis. If we're pressing down, moving down, hit us with a positive force over here. If we're moving up, right arrow, then hit us with a negative force. And if we're moving left, hit us with a positive force. Alright guys? So let's test this out. Press the green flag. Alright, so we forgot one thing. If it's doing a hit check, we need to switch to the hit check costume, which is down here, right? So we got to add this to our code. Once it does the hit check and it runs the hit check code, it's going to set the costume to the current costume that we left off on. So let's pretend we were walking. There we go. So it set the costume to the walking costume, set the variable costume to the walking costume, and then after it does the check, it'll switch back to the walking costume. What we forgot is that it needs to switch to our hitbox in order to test it. Switch to hitbox, and if you're touching the barrier and pressing any of the moving arrows, then bounce back with an opposite force. And go ahead and switch right back to the costume you left off on. Alright, so that should work nice and clean. Let's get rid of our Warrior Ken costume. There we go. And we'll press the green flag. Let's see how this works. So we still can bounce off of, looks like it's not recognizing when we're coming from the bottom, right? So if we're pressing the up arrow, we'll debug real quick. If we're pressing the up arrow, change Y by 4, it's doing that. Let's check the touch over here. The down arrow, there it is. Change Y by positive 6. Up, down, right, and left. Try one more time. Okay, now we're getting bounced back. There we go. Okay, so we have all of our walls bouncing us back, and notice that when it does the hit check, you can't even see the costume change. And let's do the check from before. If I turn around, you can see that even though my shield's touching it, touching the barrier, we don't get sucked in. So this is awesome code for interacting with walls and barriers. There's a little bit of glitching when you use the diagonal keys at the same time, but for the most part, you're good to go. Alright, I hope you guys enjoyed this tutorial, and our next one we will show you how to map out your entire level using the list function. Alright, hope you guys have a good one. See you later.